So in this video I'm going to talk about the PID control provided with the INERTIA add-on for Veristan. I'm going to be using the shipping example, INERTIA 2011 example project. So the PID control shown here on the bottom of the screen provides access to the control objects you've defined within System Explorer within the INERTIA add-on. You can set properties up on the PID control by selecting the Properties button here. In the Properties dialog, basically you can select an object to set properties for on the left hand side, and then double click and edit the particular property on the right hand side. In this case, if we want to look at the control objects we've specified, we can see that the input motor and the load motor are selected as objects to control. You can also set various column widths, colors, font sizes, and precisions for feedback, set point, and ramp rates. Now the ramp rate's also limited by a setting in System Explorer. To activate a particular control mode, you can right-click on the actual control item. In this case, we can see the input motor does not have any active modes. So right-click on it, I can choose Speed. That brings up a pending mode switch message underneath the mode itself. This is not applied until I either hit the green Apply button for applying all changes, or right-clicking on the control object and selecting Apply My Changes. For now, I'm going to also switch the load motor to torque. Now apply both of those. Now both of these objects are actively controlling, one in speed and one in torque. I can manually enter in a new set point for that particular object if I wanted to go to, let's say, 10 RPM. And again, it applies a pending message. And if I want to apply that pending message, I can hit the green button or again right click on it. So let me right click, and you can see that set point, the yellow one, which is the input motor speed set point, is ramping up. I'll do something similar with the torque. Let's move torque to 15 foot-pounds and hit apply. Let me pause that one. So what the pause button does is it issues a pause set point command to the controller to tell it to remain at, or basically hold, whatever the last set point is that the control received. In this case it was 2.78. You can also, let's say I wanted to enter another set point in but it was the wrong set point. I can clear that pending set point by hitting the discard button. I can also right click and choose to discard any changes. The PID control also displays peak and valley feedback values as specified by your feedback channel. So what it does is it analyzes your feedback channel and will display the peak and valley, roughly a min and max for that particular channel. Those settings are configured in the PID tuning under amplitude control. Basically, you can enable the peak detection here and specify the appropriate parameters. To get a little more information about a particular control item, you can right-click on it, select Properties. This will basically display the properties for that mode, such as the feedback channel that's being used, the output channel where the command signal is going, and the set point. And in this case, it's an internal set point. Also the overall min, max set point, and max rate, and whether dither is enabled or not for that set point. Now to change these values, you have to go back to System Explorer and change your system definition and redeploy. You can also add multiple PID controls to a workspace. So if I put the workspace into edit mode, I can browse to the WTI section, drag, drop PID control down. I'll just put it here, expand it, change some column widths, back out of edit mode, pop up properties, go to my control objects, double click that, and let's pick input motor. Select OK. And in this case you can see I have the input motor here and here. I can enter in a new set point here, let's say 23, apply that, and you can see that both controls basically are tracking that this set point for this mode is ramping. The system also monitors whether you're running a test or not. So let me open up a test, execute that test. The controls basically track that a test is using these particular control modes. Therefore, it does not allow a user to enter in a manual set point and basically interrupt the test. Once the test completes, the modes will return to an idle state where the user can enter in new set points. The set points displayed in the control will also track where the test ended. So if the test happened to end at a set point of 100 RPM, the PID control will display the current set point as 100 RPM.